Telescopes.
Microscopes. Glasses. All three of these things are used in everyday life, but how many of you really know how they work? Let's find out.
Them lenses. I don't believe lenses are real. Lenses are just those fake things made by Hillary Clinton to garner votes against Mr. Donald J. Trump. They're not real. Lenses have never helped anybody. Lenses are nothing. No one uses them. They're completely not even real. This is stupid. I'm not even answering these questions.
Lenses? Where would you put that on a free body diagram?
Yeah, man. I know all about lenses.
You do?
Yeah, of course. Years of experience. Years of experience with lenses, you know?
Wait.
I drive my lens to work every day.
Your lens?
Yeah, my lens. Mercedes lens. Took me like
What?
20 years to save for it, but I finally got it. It's great. Heck of a car.
Wait. I think you mean Mercedes-Benz?
Mercedes-Benz. What is a Mercedes-Benz?
Yeah, the car you drive.
No, my car is not a Mercedes-Benz. That is a Mercedes-Benz.
Yeah, okay.
This is our curved piece of glass that reflects light in an almost certain direction. I've always loved lenses since my mom gave me a telescope for my 6th birthday. But, unfortunately, in elementary school, Rick broke it because he thought I was a nerd for having so many Pokemon cards. I'll show Rick I'm no nerd. I'll show them all.
And back to Toby.
Yeah. Always good to hear from the general public. Anyway, lenses are glass objects that change the direction of the light that it comes into contact with through the process of refraction. Here's a demonstration of refraction from my good friend Sean. Sean?
Why, hello there, students. Today, we're going to be talking about refraction. Now, what is refraction? Refraction happens when light hits a medium, which is not air, and changes its direction. Like as you can see with this pencil. The light is hitting the pencil, but it's being refracted, so it looks bent when it actually isn't. Now, back to you.
Thank you very much, Sean. However, different lenses affect light in different ways. In the study of optics, lenses are either described as convex or concave. Here's a demonstration from my good, longtime friend and colleague, Dr. Mr. Professor Joey Turco.
So first, convex lenses. Convex lenses are lenses which protrude out. They produce a zoomed-in effect. So what we will do to prove how these work is we will take our lens, put it on this mark right here, and then shine the light at the very edge of the image. As you can see, while it may not appear that the light is moved, if we move it just barely out to the side, you can see that's the real position of where the light needs to be. If you shine it directly at the halfway part of the edge of the lens, we can see the distance between them. If we do this with a bigger mirror, bigger lens, however, we can see that the bend is actually bigger. The distance between the 2 points is much larger. This is because if you have a bigger curve in the lens, it'll bend farther. So if we shine it directly on the edge, you can see the distance between them is bigger, and obviously if we have a smaller curve in the lens, the distance between the two will be much smaller. Convex lenses. So now, concave lenses. Concave lenses are the exact opposite of convex lenses. They protrude in and they will reflect light away from the focal point. To show this, we have the same setup as before, so now we have a concave lens. So I see how I'm shining it at the very edge of the lens. Now if I move it just out, you can see that the real position of the light, if it was not going through the lens, would be right there. Now that I move it onto the lens, it goes over there. This is the biggest lens we have. This is the biggest concave lens we have, but if we go smaller, just as with convex lenses, we can see the distance between them is much smaller. And we do that again with a smaller, even smaller one, and we can see that, again, it's very small. So just like with convex lenses, the curve in the lens determines how far it will bend.
Thank you so much, Mr. Dr. Professor. Now, before we move on to our mirror section of the video, let's, against our better judgment, go back to the public and see what they know about mirrors.
What?
Mercedes land.
Huh?
Yeah, someone just let's never do that again. Someone just go to commercial. I need a minute. And we're back. Sean, please wow us with our next topic.
Thanks, Toby. And now for our next demonstration, where we're going to be talking about mirrors. What are they? What do they do? And how do they work? Now, there are three types of mirrors. Planar mirrors, convex mirrors, and concave mirrors. Right now I'm going to talk about planar mirrors. Planar mirrors are flat mirrors that reflect light in a straight line. So, mirrors work like this. They have an angle of incidence and an angle of reflection. The angle of incidence is the angle in which the light hits the mirror, and the angle of reflection is the angle that the light reflects off of the mirror and hits something. And as you should always remember, the angle of incidence is always equal to the angle of reflection. Now to show concave and convex mirrors. Concave mirrors are used to focus light from a beam into a single focal point, like with flashlights. And convex mirrors are used in blind spot detection mirrors to see cars in one's blind spot. Now here's a demonstration from my colleague, Joe.
So right here, I have a convex mirror and a concave mirror on the same mirror. So to show their properties, I will take it right here and shine a laser at the very edge of the mirror. As you can see here, as I shine at the very edge, it will reflect and hit the inside of my hand. If I do the same thing with the convex mirror, however, it will reflect and hit the inside of my hand. So what we can do is we can show that convex mirrors will reflect light away from the middle, while concave mirrors will reflect light towards the middle.
Now we're going to talk to you about reflecting and refracting telescopes. Now, reflecting telescopes use mirrors, while refracting telescopes use solely lenses. Here's Sean to give you more information on reflecting telescopes.
Reflecting telescopes use one or more primary mirrors to reflect light into another mirror or lens. Now, there's two types of reflecting telescopes, the Newtonian telescope and the Cassegrain telescope. The Newtonian telescope uses a convex lens to focus light onto the primary mirror, which then it reflects light back onto the secondary mirror, which reflects light into the eyepiece. The Cassegrain telescope uses a lens which only gets rid of chromatic aberrations and does not focus the light at all. Light passes through this lens down an optical tube into a concave mirror. Light then bounces off this mirror into the small convex mirror, which then focuses light down the eyepiece. And now, Joe will talk to you about refracting telescopes.
So refracting telescopes. They are unlike reflecting telescopes in that they do not use mirrors. The most famous of this type is the Galilean telescope, which is the one that you see pirates use. Pirates are cool, so Galilean telescopes are cool. Yeah.
Yar.
Yar. So Galilean telescopes work by having a convex lens on the very end to focus the light down the optical tube. Then that light will hit and refract in a diverging lens or a concave lens, which will bend light back straight towards the eyepiece. But the only problem with these type of telescopes is that they suffer heavily from chromatic aberration, which is like the shifting of light due to different wavelengths, right? So there'll be red shifts and blue shifts. So these aren't really used much in industry, and also they don't have very good focusing power due to them not using mirrors. So they're primarily just either used by 15th century pirates or explorers, and that's really it. They're not that useful anymore, but they're cool. Back to you two.
And that concludes our journey through optics. Tune in next week for our video on nuclear fallout with live demonstrations. See ya! Mercedes Land. Oh God.